Introduction. Related rate is a rate at which a quantity changes as a result of connecting it to other values with known rates of change. We have seen that derivative can be used to calculate the rates at which quantities change over time. If two linked quantities change at different rates throughout time, the rates at which they change are said to be related. We consider a number of problems in which two or more linked values are changing. Thus, we study how to figure out what the relationship is between their rates of change. This normally involves formulating an equation linking the two variables and determining the equation's derivative with respect to time. In this situation, we can say that the rate of change of the length of the cable, y, is related to the rate of change of the distance between the brick and the crane, x. In this case, we can say that dy over dt and dx over dt are related rates because y is related to x. So what is differentiation? So differentiation is one of the two most significant concepts in calculus. It is also a technique for determining a function's derivative and also a mathematical procedure for determining the instantaneous rate of change of a function depending on one of its variables. So when do we apply differentiation? So first, rate of change of a quantity. This is the most common and important use of derivative. For example, we may use the derivative form dy over dx to examine the rate of change of the volume of a cube with regard to its decreasing size, where dy is the rate of change of the cube volume and dx is the rate of change of the cube size. Next is applications in real life, so we can use differentiation to calculate the profit and loss in business using graph. Besides that, we can check temperature variation, calculate the speed or distance traveled in miles per hour, kilometers per hour, or other units. And in the field of seismology, it's common to look for the earthquake's magnitude range. So next is other applications of differentiation. So first is analysis of functions 1. The terms increasing, decreasing, and constant are used to describe how a function behaves as we move from left to right on the graph. Let f be a function that is differentiable on the open interval ab. If f prime x is more than 0, then the f is increasing on ab. If f prime x is fewer than 0, then f is decreasing. If f prime x is equal to 0, then f is constant. The derivative of a function f can tell us if the graph of f is increasing or decreasing, but it cannot tell us whether the graph is curving downwards or upward. So this is the picture on how we can determine the concavity of a graph. Second, we have analysis of functions 2. For relative extrema, we have relative maximum, which fc is greater or equal to fx for all x in AB. Relative minimum is when fc is less or equal to fx for all x in AB. For relative extremum, it has either relative maximum or relative minimum at c. For first and second derivative test, it is to determine whether the critical points are relative maximum or relative minimum. Third one is applied maximum and minimum problems. To solve the maximum or minimum problem with calculus, we must first understand what is being asked. We must translate the problem into a mathematical form, which is a suitable formula of geometry formula that we can solve, and we must verify that our mathematical solution is a true solution to the original problem. Next is Rolle's theorem and mean value theorem for differentiation. So for Rolle's theorem, let f be differentiable on AB and continuous on bracket AB. If fa is equal to fb is equal to 0, then there is at least one point C in AB where f prime C is equal to 0. For mean value theorem for differentiation, let f be differentiable on AB and continuous on bracket AB. Then there is at least one point C where the tangent line to the curve parallel to the secant line join A and B.
Moving on, these are the problem statements for related rates. The first one is determining the rate of change of a quantity by comparing it to other values whose rates of change are known. In this case, the known rate is the rate of the cable being pulled through the pulley, which is 20 meters per minute. The second problem statement is finding the suitable method of differentiation to use and constructing the mathematical equation. There are two main methods to solve related rate problems, which are the chain rule method and the implicit method. And the final problem statement is solving the derivative and giving the final answer in the required form as stated in the question, which can be in either radicals, fractions, or even decimals. Next is the objective. The first objective is to find the rate of the braid approaching the crane when 125 meters of rope is out. The second one is to construct the equation by using chain rule method and or implicit method. And the last one is to be able to solve the equation and give the final answer in radicals.
Problem solution. The question is, a crane is pulling a braid on the ground with a cable that is attached to a pulley. The pulley is hanging at 10 meters above the ground. If the cable is pulled through the pulley at a rate of 20 meters per minute, at what rate will the braid be approaching the crane when 135 meters of rope is out? Give your answer in radicals. I interpret the question into a triangle, which y equal to cable, s equal to distance, and 10 meters is the height. As we know, dy per dt is 20 meters per minute, which is the rate of the cable pulled through the pulley, and I change it into negative because the length of the cable is decreasing. And we want to find out the x per dt, which is the rate of the braid to be approached the crane, and we know that y equal 125 meters, which is the length of the rope. To find the x per dt, we use chain rule, which is dy per dt multiplied by dx per dy. Firstly, I use theorem Pythagoras to get the value of x, which is y squared equal to x squared plus 10 squared, and I insert the value of y, which is 125, and get x equal to 6155 to 5, and I simplify it into 15 69. I use implicit to get the value of dx per dy, which is d per dx y squared equal to d per dx x squared plus 10 squared, and differentiate it into 2y dy per dx equal to 2x, dy per dx equal to 2x per 2y, and simplify it into x per y. To get the value of dx per dy, I insert the value of x and y, which is 125 per 15 69. Lastly, I use chain rule to get the value of dx per dt by insert the value of dy per dt and dx per dy, which is negative 20 multiplied with 125 per 15 69, and get the final answer, which is negative 500 69 per 207 meter per minute. Conclusion. We managed to construct an equation to find the answer of the question by using chain rule with the addition of implicit, theorem Pythagoras, and the major rule is derivative. Furthermore, we find the rate of the braid approaching the crane when 125 meters of rope is out and get the answer in radical, which is negative 500 69 over 207 meter per minute. After all, differentiation is a main topic in calculus, which we can use it in many formula. In fact, it also contributes in our real life, not only for education but also in medication.